Hi, my name is Mrs. Tan and I'm one of the 4 geometry teachers at Ridge. We're going to be using videos to introduce you to new topics in geometry, and all 4 teachers are going to be working together to make them. I'm doing the first one on section 1.1, points, lines, and planes, which is a foundational topic in geometry. So section 1.1 has a lot of important vocabulary that's going to continue to be important throughout the entire year. So it's really important you pay attention and take notes. I would suggest printing out the worksheet that we posted, the blank one, on Google Classroom so that you can take notes right on the worksheet. So the first vocab word that we're going to talk about is a point. So a point is a single location in space. It has no dimension and it's named with one letter. So even though the points that you see, like point E, point F, point G, point S, point V, all these points look like they have a dimension to them, right? Like if you went to go measure it, it would have some measurement. But that's just because if we didn't do that, then we wouldn't be able to see them at all. But really, points have no dimension at all. So they're just a location in space, and they don't have a length or a width or anything like that. For the example, as you can see, they're named with one single letter. So point E is just called E. The next vocab word is a line. So a line has one dimension and it goes on forever in both directions. So to name a line, you would have to name it with any 2 letters that are on that line. So for example, EG would be the line that connects E to G, and then it's going to continue on past E and past G. So it's going to have arrows to the left and to the right of it. Notice that when you name a line, so if you were to name the line using proper notation, that would be here, notice that the segment on top is not just a segment, it's a line that has arrows on both sides. So I'm going to highlight this a little bit because it's kind of hard to see in like typing. But here, if you have a line, you're going to have to put arrows on either side when you're naming that line. So it's PQ with a line on top. And that's how you would name line PQ. And again, PQ would be this line here. All right, so the next one is array. So array is kind of like a line, except that it starts with one endpoint, and it goes on forever in only one direction. So for example, ray FH would be the ray that starts from point F, so that would be its endpoint, and then it goes forever, but only towards the direction of point H. So F to H would be the ray FH, or you could call it FG, and that would be the same ray. So the only thing that's really important when naming a specific ray is naming it with its endpoint. So its endpoint here is F, and then you can use any terminal point in the direction where it goes. So you could call it FH or FG. Okay, now if we look at ray HG, it's going to go the other way. So again, H is the first letter in our name, so that means that that has to be the end point. So it's going to start at its end point, which is point H, and then it's going to go in the direction of point E. So that means it's going to go this way. So that means that ray HE, even though it's shown to be going to the right when you name it, it goes in the direction of its second letter. So it starts at H and goes towards E, and that would be ray HE. You can also name this ray HG or HF, and it would still go on and on forever in the direction of E. Also, notice that when you name FH or HE, you put a line with a single arrow always going to the right. So this arrow always has to go to the right. Arrow always right. And that's just notation. So that's just how mathematicians talk to one another and how they communicate. So if you had the arrow going in the opposite direction, that would be incorrect. All right, so the next one is going to be segment. So a segment is just a piece of a line. So that piece doesn't go on forever in either direction. So for example, segment PT would start at P, so it would begin at P, it would end at T, and it would only contain the piece of the line that's in between points P and T. So it's not going to go past P or past T. Then we have EH. So this is another example of a segment. Notice for segment bars here, when you're naming it, it doesn't have arrows on either end. So you would just name it EH with a segment bar on top. And that segment goes from E to H, and it's only the segment there. It does not include the arrows to the left and to the right of it. Okay, so next is a plane. So a plane is kind of hard to visualize, but basically think of it as like a piece of paper. It doesn't have any depth to it at all, or thickness. And it goes on and on forever in the directions like that are towards the end of the paper. So if you look at this plane here, VSP, that would be this like light pink plane. And notice that it looks like it's coming out of the paper, and that's just to show that it has 2 dimensions there, and it's drawn in 3 dimensions. So in order to show you this a little bit better, I'm going to give you an example that's drawn out using a program called GeoGebra. And we're going to be using GeoGebra in our class this week to draw our own planes and our own lines, and we're going to work together in groups on this. So here is the same drawing that's on this PowerPoint. So notice it has point V, S, P, T, etc. But now it's drawn to the point where we can move it around. So as you can see, the plane has no thickness whatsoever, but it has 2 dimensions. And you have to think of this as it actually does go on and on forever, to the left, to the right, forward and backward, but you just can't see it because we can't picture a plane going on and on forever like that. Also notice that line QP is going through the plane, and we can see that because Q is above the plane, P is on the plane, and P is the point of intersection of that plane. Notice that you have hidden lines. These are dashed lines showing that this section of the line here is underneath the plane. So when the plane is above it, you see this line with dotted lines. Also notice that line ST is actually just on the plane. So this is on plane VSP. Okay, so I'm going to name the plane VSP. I can also name this plane VST or VPT or VTP or PVT. So pretty much any 3 points that are non-collinear, so they're not on the same line, any 3 points on that plane. So for example, if I named this plane SPV, then I would know that it would have to be this teal plane right here. There are no other planes that would go through those 3 points. So that's how you would name a plane, with just 3 letters. Now also, be careful not to name your plane with 3 letters that are on the same line, because not just one plane can go through letters that are on the same line. There's an infinite number of planes that can go through those 3 points. So for example, if I went to draw a plane here, and I went through S, P, and T, right? Now, if I don't pick a point that's not on that line, then I could have a plane that contains points S, P, and T, but it's not the teal plane. It's a totally different plane. And you can draw an infinite number of these planes going through points S, P, and T. So using 3 letters that are on the same line to name a plane does not help us whatsoever. So again, let's take a look. Here we're calling this plane VSP. You could have also called it TVS or any combination of those 3 points. Okay, so next we're going to talk about some other important vocabulary. So there's opposite rays. Opposite rays are 2 rays with the same endpoint, and they go in opposite directions. So for example, if I had point F as my endpoint, then a ray that starts at point F and goes in one direction would be FH. So that's this ray. And then a ray opposite to that would be FE. So ray FH and FE are opposite rays. An example of rays that wouldn't be opposite rays would be rays that, like, for example, if you started at P and went to Q and started at P and went to S. Those are not opposite because they don't go in opposite directions. Also, make sure that they have the exact same endpoint. So if they don't have the same endpoint, they are not opposite rays. So here, same endpoint is really important to know. Okay, next is coplanar points. So coplanar points are any points that are on the same plane. So for example, you could do points V, S, P, and T. All four of those points are on the same plane. Now, one thing that's really important about this is that any 3 points are coplanar. Any 3 points. So this is super important. And that's because if you take any 3 points in space, any 3 points at all, you can make a plane out of those points. So if we go back to our example here, okay, notice that if I used points S, T, and Q, those 3 points would have their own plane. Collinear points. So collinear points lie on the same line. So that's pretty intuitive. And collinear points, you could have any number of points, but any 2 points are collinear. So if you connect any 2 points in space, any 2 points at all, they're going to have a line that connect them. So any 2 points are collinear, any 3 points are coplanar. So we're going to talk a lot about intersection when we do our group work activity in class. But just know for now, you can write this in your notes, that when 2 lines intersect, they form a point. And when 2 planes intersect, they form a line. So if you think about your ceiling and your wall, where those 2 planes intersect, the plane of your ceiling and the plane of your wall, you can see that edge where they intersect, that's a line. Okay, so now I want to have you guys try some problems along with me. So the first one is, what is another name for line LO? So if we look at line LO, LO is this line here. So we could also call this line LN. Now when you're naming a line, make sure you put a bar on top and arrows going in both ways. So think about what other ways you can name line LO besides LN, right? There's a lot of different combinations that you can use. The next one is to identify a line, a segment, and an array. Use appropriate notation. For this one, I'm going to say PN as my segment. I'm also going to say PN as my ray. Notice that the ray has the arrow going in one direction. And then I'm going to say PN, the line. And each of these mean different things. Segment PN, ray PN, line PN. Name a pair of opposite rays. So for this, there's really only one option here, and you would use point N as your endpoint, and then the rays that are opposite would be NL and NO. Next, name 3 points that are collinear. So any 3 points that are on the same line, and for example, that could be L, N, and O. Next is name 4 points that are coplanar. So we have L, N, O, and M. And those are all on the same plane. Let's name 4 points that are not coplanar. So we can do something like L, M, O, and P, because L, M, and O are all on the same plane, and then P is way up here. So that is not on that same plane. And then for G, name the intersection of the two lines. So the intersection of the two lines would be point N. So if you want, you could put point in front, but just N would also be acceptable. Also, one last thing that I want to mention is that, or for letter E, you could have either said LNOM, or you could have actually said LNOP as 4 points that are coplanar. And that's because if you think about points L, N, O, and P, even though P is not on the plane that's drawn, P is on a plane that exists in space that connects through all of these points. So L, N, O, P are technically coplanar because there is a plane. If you were to draw this whole plane, right, it would be kind of like intersecting that other plane. And those would be coplanar. So think of that plane as like cutting through the other plane. But M would not be on that plane. So this is an example of points that are coplanar, but there's not a plane that we can actually see that's drawn that goes through them. But that doesn't mean they're not coplanar. We'll do a lot more practice with this in class. And for letter F, if you got NOMP or LMOP or LMNP, any of these are right. So if you were trying these and you got something different from what I showed you, then just so you know, these are all correct answers. Also, for example 2, we are going to be going over this in class when we see you next. And that's it. So in class, we're going to be doing a lot more with this. And so make sure that you come to class prepared with any questions that you have from the video. Thanks.